These are my enthalpy and calorimetry quiz corrections. To solve for number 1, use the equation Q equals mc delta T, and then you plug in the numbers for the variables given in the problem. So Q equals 60 times 4.18 times 4.6, and you get 1,153 joules or 1.153 kilojoules. To find the moles of ammonium nitrate, you take 3.88 grams ammonium nitrate and divide it by its molar mass, 80.06 grams, and you get 0.0485 moles. To find out H, you take 1.153 kilojoules and divide it by 0.0485 moles, which gives you the answer of 23.7 kilojoules moles absorbed. Although I used the correct equation to begin with, I used the wrong numbers. I used 63.9 grams instead of 60 grams. For problem 2, you use the equation E equals C delta T and you plug in the numbers given. So you have E equals 7.854 times 7.13 to get E equals 56 joules. Using stoichiometry, you can convert 2.2 grams of quinone to moles by dividing by its molar mass, 108.1 grams, giving you 0.2035 moles. After this, we plug in the numbers that we just calculated into the equation negative E over mole to solve for heat of combustion, and we get negative 275 joules over moles. For problem 2, what I originally did wrong in the quiz was that I used the wrong equation. I used mc delta T instead of just c delta T. For problem 3, I got the right answer but accidentally left out the negative sign. For 4b, use the equation standard delta H equals sum of standard delta H products minus sum of standard delta H reactants. The sum of standard delta H products is negative 1,280.1. The sum of standard delta H reactants is negative 1,211.76. Plug in these numbers into the previously stated equation and you get negative 1,280.1 plus 1,211.76. The standard delta H of the reaction is negative 68.3 kilojoules moles. What I did wrong in the original quiz is that I accidentally put SiCl4 on the product side instead of HCl. For problem 5, we begin by using the equation delta E equals Q plus W. Using the numbers given to us in the problem, we can plug in it into the equation, so we have negative 102.5 equals 52.5 plus W. Then using simple algebra, we subtract 52.5 from both sides, and W equals negative 155 joules. After we take negative 155 joules and divide it by 101.3 to convert it to negative 1.53 liters. We use negative 1.53 liters for W in the equation W equals negative P delta V. Therefore, we have negative 1.53 equals negative 0.5 times delta V, which is 58, minus VI, which is the initial volume. Again, we use algebra and divide both sides by negative 0.5. Then to isolate the initial volume, subtract 58 from both sides, and we get initial volume equals 54.94 liters. What I did wrong in the quiz was that I used the equations given to me in the wrong order and I plugged in the wrong numbers given as well. And divided by 4 moles because that is how many moles of ammonium that is present in the balanced equation, and multiplied by negative 1,170 kilojoules to get the answer of negative 256 kilojoules. What I did wrong in the quiz was that I missed a step and forgot to convert to moles and skipped that. I needed to convert from grams to moles and then moles to kilojoules.